Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at Statistics 1, Distributions, Part 3B, Normal Distribution. Part 3A and Part 3B are both on normal distribution, but in Part 3A, the last video, I looked at the concepts involved in understanding the details so that you can be successful in the question type. In this video, we want to actually get into the questions and work our way through them. So as a quick reminder, there are three things that you need to keep in mind in order to be successful. First, you need to know this chart here. The chart is not provided for you, although the notation is provided in the formula sheet, but the chart is not. You need to know your way through the chart. So once you have properly notated this as a normal distribution and have properly set up your probability statement, then you need to be able to follow this pathway through from the number that you're looking for or that you're calculating the probability for, goes down into the standardizing formula where the mean and standard deviation come from the parameters. You calculate the standardized value, which we call the z-score. Then you look up the z-score in your phi-z chart, and that gives you the probability, which is your answer to the question, assuming you're working through a normal direction. Of course, Cambridge is going to mix this all up for us, but you need to know where you're at in the system. Second thing that you need to know are your limitations to your normal distribution chart that is provided for you in the formula sheet. So the limitations are, number one, it only works with less than values, meaning this inequality needs to be a less than because your normal distribution graph shades to the left, the less than direction. Second of all, your phi-z chart only does the top half of the graph, meaning from 0.5000, 50% to 100%. It only does the right side. So you have to understand the symmetrical nature of this chart. So in understanding this, then you can figure out the adjustments that you need to make. For example, if your inequality is a greater than, or if your probability is less than 0.5000, or if your z happens to be negative instead of positive. So those are adjustments that you need to make based on your understanding of the phi-z chart. The third thing that you need to be able to do, of course, is read the chart and understand what it's telling you, either reading it from the z value to the probability or from the probability back to the z value. Those are the things that we're going to see play out in these examples. Now, so let's just jump into our first example and look at it, and we'll explain it as we go. So here's our first example here. Says the volume of ink in a certain type of ink cartridge has a normal distribution with mean of 30 milliliters and a standard deviation of 1.5 milliliters. So remember, mean is your measure of central tendency. It's the location value that you kind of recognize as representing the data. Then the standard deviation is the measure of spread away from your data. So for one standard deviation would include 68% of your data. Then it says people in an office use a total of 8 cartridges of this ink per month. Find the expected number of cartridges per month that contains less than 28.9 milliliters of this ink. Now, this question is basically straightforward. However, at the very end, it has added one extra step at the end. Notice it's not asking for a probability. The answer to a normal distribution is a probability. it goes beyond that and says, find an expected number out of 8. So there's a total of 8. You're finding an expected number. So this extra step at the end means that you need to use your probability and multiply it by 8 to see how many of these cartridges contain less than 28.9 milliliters of ink. So whenever you see that expected number, you have to get your probability and multiply it by the total to see how many that you would expect. Okay, so now that we have that, let's go back to our board here and look at some of the key things. The good thing for you is that when it's a normal distribution, as opposed to binomial or geometric, the Cambridge question actually says it follows a normal distribution. But I don't want you to be dependent on Cambridge telling you the type of distribution. I want you to think through it in a systematic manner. The first thing you need to look for is your data discrete or continuous? Because discrete data goes with binomial and geometric. Continuous data goes with normal. So the first thing you're looking for is this is dealing with volume of ink. Volume of ink. Volume does not have certain set values it has to take. Volume can be anything. Whatever milliliter you have, it can be halfway in between it. So volume is a continuous concept. It's not discrete. It doesn't have only certain volume values that it can have. It can be anything in between the range. So this is important for us to identify continuous, which is what identifies us using the normal distribution. The question does say it, but again, you need to think it. The next thing that it does is it provides for us the parameters, the mean and standard deviation. So let's go ahead and set up our notation that we have. So our random variable is going to be, which is representing volume, by the way. Our random variable, which is representing volume, is distributed normally. So we've chosen the correct distribution. And the parameters that go with normal are the mean and variance. Now this you have to be careful because the questions will go back and forth between giving you variance or giving you standard deviation. You need to pay attention to which one it's giving you. It's giving you standard deviation, but the parameter is variance. Now you don't have to go ahead and square it. You can just write it as a square. Okay, so this is supposed to be variance. So 1.5 squared is the parameter. So now we have our notation correct. Then we move on to the probability statement. Well, it says find, there's our verb, the expected number, meaning we have to multiply the total by our probability to get the expected number. So where is our probability going to come from? It's going to come from this statement right here. So now we can make our probability statement is X is going to be less than 28.9 milliliters. Okay, so we want to find the probability that these cartridges end up being less than 28.9 milliliters. Now, with binomial and geometric, because they are discrete values, the inequality was very important because if you don't have the equal to sign, you have to jump to the next discrete value. Because normal distribution is continuous, it doesn't matter whether or not you have the equal to or not in the question. Just follow what it says. If it says less than or equal to, but it doesn't really affect your numbers because it's continuous. It goes all the way up to that point, whether it includes it or not. The area behind it, the probability is still the same. So we don't have to worry about that, which is good, but we do have to pay attention to the inequality because it is important for our phi z chart, which only does less than. This is less than, so we're good to go for that. Now, to find the probability, this is a very straightforward going through our map here. So we have our x value, so we're going to bring this down, and we need to find our z. We need to standardize this data set to our standardized model so that we can then use the phi z chart. So z is going to equal, this is our standardized number that we're looking for, 28.9. Remember, we subtract the mean, so that's what lines us up on the 0 part of the chart. And we divide it by the standard deviation, which is the 1.5, not the 1.5 squared. And this will give us the z number that we're looking for. So look that up really quick in your calculator. So we do 28.9. You probably notice right away that we're going to end up with a negative value. And so we get a negative 0.733. Now remember, take your z to 3 decimal places. So we get a negative 0.733, and this one is rounded down because the number after it's also 3. And now we see that it's negative. So we got to take this and put it into our phi z chart. And our z is this negative 0.733. So let's go to our chart. And if we go to our chart, here's the chart down here. Notice all of our z numbers. Here's the first decimal place over here. Here's the second decimal place, and over here's the third decimal place. Notice our z is only positive. Our z was negative. So this is one of the places you have to make an adjustment. So to do that, we use the positive value. So instead of looking up a negative 0.733, we're going to look up a positive 0.733. So here's a positive 0.7. Here's the 3 over here. So that gives us a 0.7673. So I'm going to write that down here, a 0.7673. Then we need to add to it another 3, which is over here. And if I take that down to the 0.7 line, here's the 0.7, follow it across to the 3, we have to add 9. So when we add 9, we now have 0.7682. Okay, so 0.7682. So now let's come back to the board. So we looked up 0.7, cross-referenced 0.7, which was the left column, the first decimal, if it has a whole number. So 0.7, 1.7, 2.7, that left column has a whole number in the first decimal place. So this was 0.7, cross-referenced with the top number, which was a 3, that gave us 0.7673. And then the third number, which was in the right-hand column, gives us the plus 9. And of course, when we add 9, we're not adding it to the front, we're adding it to this last digit here. So 73 plus 9 is 82, so we get 0.7682. However, we looked up the positive z. So since we changed this to a positive z, the way we adjust for that is we have to do 1 minus this probability. Remember, it's symmetrical. So a 0.733 standard deviation in the positive direction is going to equal a negative 0.733 standard deviation in the negative direction, but 1 minus that. Okay, so that's symmetrical. So 1 minus this gives us a 0.243, or 3, sorry, 0.2318. So we get 0.2318. This is our probability for the negative 0.733 standardized number. Now this is the probability that is our answer to right here. If we were to come up and bring this back as our answer, 23.2318, or in other words, 23.18%. But what we want is this percent of 8. In other words, this is the probability, but now we want the expected out of 8. So out of 8 means that we're going to take this here, multiply by 8. So we take 0.2318 times 8 equals 1.85. So we would expect 1.85 of those cartridges, or if you wanted to, you could round it up to 2. We would expect 2 of those cartridges, or 1.85 of those cartridges, to be less than 28.9 milliliters under these conditions. Okay, so this was the answer right here. Had one little extra step at the end because it was an expected value out of a total, but you still have to find the probability. Our probability went straight forward through the map, just like it should, with the exception that our z was negative and our phi z chart only takes positives. So we had to use the positive number and then do 1 minus to adjust for that. Okay, so that was our first question. Pretty straightforward. Notice the math is not difficult. Most students don't struggle with the math. This is very relatively simple algebra as far as the math goes, but it's the concepts and the details that you really need to pay attention to. Let's look at our next example. Okay, here's our second question. Part 1 of the next question says the time taken in minutes by a ferry to cross a lake has a normal distribution with a mean of 85, that'd be 85 minutes. And in other words, the average time to get across the lake is 85 minutes, and a standard deviation of 6.8 minutes. So this first part of the question says, find the probability that on a randomly chosen occasion, the time taken by the ferry to cross the lake is between 79 minutes and 91 minutes. Okay, so that's what we want to look at there. Let's go back to the board. Again, let's think our way through. They already tell you it's normal distribution, but you want to be clear in your thinking. So the first thing we're looking for, is it discrete or continuous? The reason why I keep going back to that original question is these Cambridge questions, as you look at the whole question, you know, the part 1, part 2, or part A, part B, part I, they sometimes jump back and forth between a binomial and a normal, and it will switch right in the middle of the problem. So you really need to, at every part, you need to adjust your thinking so that you don't get confused. That's why I keep going back to this first question. So in this particular part, it's talking about time in minutes. And minutes, if you're measuring minutes, it's not discrete values, like only this many minutes, only this many minutes. It can take any value in between. So time is continuous when you're talking about measuring minutes to get across the lake. Gives us mean and standard deviation, which is our parameters. So let's go ahead and set up our notation first. Please write and get used to writing your notation first. Some students just jump into the probability and they start working through a problem and they don't write the notation down first. But it's important because it organizes your data for you. So here's our random variable, which is time. It varies normal, so that's our distribution, with a mean of 85 and a standard deviation of 6.8. So we're going to put 6.8 squared because that's variance is our parameter. Then we want our probability. Well, notice that our probability is now between two values, okay? So if we're looking at, say, 0 as our point of reference, that means we're looking at the probability of 79 to the probability of 91. Remember, your probability is from that point left, the less than value. So there's a certain probability of your time being 79 minutes. There's also a certain probability, of course, a higher probability or a higher value number, percent, that you're within 90, less than or equal to 91 minutes. So if you want the between, if you want this between value, you have to subtract the larger one minus the smaller one. So we want the probability of the 91 minus the probability of the 79. So when you make your probability statement, you can make it like this. The probability that your random variable, and our random variable is t. Actually, let's change this to 79. And we'll include, like I said, it doesn't really matter whether you put the equal to or not. It doesn't change for normal because it's continuous. Here's our x. Here's our random variable, which represents time. And actually, if you wanted to, you could even call it a little t here. Okay, so how you put the variables, not super important. X is your random variable. It represents time. So what is the probability that our time is between 79 and 91? So this is one way of writing it. It's between these two values. You could also write this as the probability that your random variable is less than or equal to 91 minus your probability that your random variable is less than or equal to 79. So you could also do it this way. This is what you're going to be doing with the math. Since you don't really have a math for between, you're going to take the larger one minus the smaller one to get the between. So that means we have to do this over here twice. Once for the 79 value and once for the 91 value. So we're going to do the 91 probability minus the 79 probability. Excuse me. So the 91, let's plug that in over here. Let's make two separate ones. So we need a z number. We have to standardize it. Equals 91 minus the mean is 85, over the standard deviation is 6.8, and we need to calculate this. So let's go ahead and do that real quick. 91 minus 85 divide by 6.8. 0.882. Remember, you need 3 decimal points. So 0.882. Then this one over here is going to be 79 minus 85 divided by 6.8. And what's that give us? So let's check that really quick. 79 minus 85. Obviously, that gives us a negative number. Divided by 6.8 gives us a negative 0.882. Now that's interesting. These are the same numbers, but one of them is negative. What that means is these two numbers are exactly the same distance away from the mean. If you think about it, if you take 85 and you add 6, you get to 91. If you take 85 and you subtract 6, you get to 79. Because the z numbers are the same value, absolute value, but this one's positive and that one's negative, meaning they're on opposite sides of the mean, but the same distance away. They don't have to give you numbers that are the same distance away. They could have said, what is the time between, say, like 90 minutes and 50 minutes? So just recognizing that these numbers are the same shows that you have symmetrical values around the mean. Now we need to look these up. Now that we got the z value, we need to look it up in the phi z chart. So what we're looking for here is the phi of 0.882. So we need to put our z into the phi z chart. And we need to do it over here, but notice it's negative. So we're going to have to make adjustments again for this one because there's no negative z in our phi z chart. The good thing is these two are the same number, so we only have to look it up once. So let's go back to our formula sheet here, to our normal distribution function that you see right here. And we want to look up the value 0.882. So that would be a 0.8 right here. Then a second 8, which is up here. You cross those. So 0.8 with 8 is 0.8106. So 0.8106. Then we need to add the 2. The 2 is over here. So notice here's the 0.8, here's the other 8, cross-referenced with the 2 is 5. So we need to add a 5 to it. So put plus 5. Now we can come back to our board here. So we looked up the 0.8. That's on the left column, cross-referenced with the 8 in the top row, which gives us 0.8106. Then the 2, which is in the right column, said to add 5. So this gives us, when you add 5 to 6, you get an 11, so 0.8111, which would actually be the same value as this one. This would also be a 0.8111, but because it's negative, that means that we need to do 1 minus that. And that's going to give us 0.1889. Okay? So 0.8111, straightforward positive z to probability. This one was a negative z, so we had to look up the positive z and then take 1 minus that, and we get this. So we found the 79, we found the 91. Now to find between it, we need to subtract the larger from the smaller. So our 81% minus our almost 19% here gives us a value of 0.8111 minus 0.1889 gives us a 0.6222. 0.6222. And that is the correct answer. This is the probability In other words, this is a decimal, so if you changed it into a percent, they don't ask for percent. You can put the decimal. This is the correct answer. But if you're thinking about it as a percent, 62% of your, there's a 62% chance that your ferry will get across the lake between 79 minutes and 91 minutes. 62% chance, meaning you're most likely to get across the lake within that time span. Okay, that's part one. Notice these questions are a little bit involved as far as the pathway. That's why you need to train your mind mentally first. That's why I had the whole video 3A on the concepts, so that you could get your mind ready, and that way when you work through it, you're not intimidated by these little details that jump out at you, but you understand how they're fit with this map here. Okay, now let's go to the part two. I'll set up for that. Okay, let's look at the second part of this problem. Notice I kept the first part because our distribution and parameters are the same. Let's look at the second part of the question here, which says, here's part II. Over a long period, it is found that 96% of the ferry crossings take longer than a certain time, t minutes. Find the value of t. So now what it's doing is the 96% is actually your probability. It's giving you the answer to this probability thing. It's giving you this part right here. And it wants you to find t, which is your variable. That's this little t right here. It's your small x in this random variable of big X. So that's what it wants you to find. So now you're working backwards. So this is a backwards one. It gives you the answer and you're finding the number, the value. So first of all, we have our notation didn't change. It's the same probability, same ferry crossing. So this is the same. What's different is now our probability statement. So our probability statement is our t, or our random variable x, longer than t minutes needs to be greater than t minutes. And the answer to our random variable being longer than or greater than t minutes equals 0.96. 96% as a decimal is 0.96. So they've given us this. We have to find this. So we need to work backwards. We need to work from our probability to our z number and then back up to our the letter t. Now, there is an issue here that you should recognize. That is, our phi z chart does less than. This is a greater than. So there are two ways that you can adjust for this greater than. You don't want to forget it. That's why I'm pointing it out now. You want to have in your mind when you start this problem that you have to make an adjustment. So eventually, we want this to flip to a less than, because that's what our phi z chart gives to us. It gives us an answer in less than form. One way that we can adjust for that is to do 1 minus the probability. But if we do 1 minus 0.96, the value that we get is going to be less than 0.5000, and that's another restriction of our phi z chart. So we can't go below 0.5000. So since we can't do 1 minus the probability, the other way that you can adjust for this is to just look up the 0.96, get the z number, but then make it negative. So if you can do the 1 minus probability, which means it will jump it above 0.5000, then that's good. If you can't, like we can't here, then you got to look up the number and change the z sign to negative. So that's what we're going to do. Let's go to our probability chart here. And we want to look up 0.96. Now remember, now we're not looking at the z numbers. Now we're looking at the probabilities and trying to find the z number. So do I need to, let me get rid of this out of the way since we've already looked at it. And now let's blow this up a little bit. So we're looking for 0.96. Here you see 0.9545. Here we go right in here. Here's 0.9599. 0.96 has already went over. So you want the number right before it goes over. And so the first two decimals, we want 0.96. So we start with 1.7. So we're taking this, our 0.96. We're going back to our phi z chart, and we're getting 1.7. 1.7, that's this one, 1.7. And then we want to go up here to this one, cross-reference with 5. That's the second decimal. So 1.75. Then when we come down here to our 0.9, in order to get a 0.96, if you're following my cursor there, we need to add 1. We need to change this 599 to a 600. So we have to add 1, which is this number right here. So I follow this up, which is a 1. That's the third decimal. So I get 1.751. So let me shrink that back down. Let's get out of here and go back to the board. So when we looked up 0.96, we saw 0.9599. That cross-referenced with the 1.7 on the left column and the 5 on the top row. Then we needed to add a 1 to that. It was a 0.9599. We needed to add a 1 to it so that we can get our 0.96. So this one cross-referenced to the 1.7, which gave the first decimal, with the 5 gave the second. We needed to add 1. We looked in the right-hand column, and when we followed it up, it also gave us a 1. This is our z number. Now remember, we need to flip this to a less than. We couldn't take 1 minus probability, so that means we need to change our z to negative. So now we're looking for t minus the mean, which is our 85, over the standard deviation, which is 6.8. So this is what we're solving for here, the t. So if I solve for t and write it in an algebraic statement over here, we're going to have to multiply. T is going to equal the negative 1.751 times 6.8, and then we need to add the 85. Okay, so I don't know if that, maybe that didn't show up very well. Let me make it a little clearer. So t equals the negative 1.751 times the 6.8, which multiplies it over here, and then add the 85. That will give us t. So let's do that on our calculator really quick. So a negative 1.751 times a 6.8, and then add 85, and that gives us 73.09. We want 3 significant figures, so our t for our answer is going to be 73.10. minutes. So what this is saying is that 96% of all the ferry trips will take longer than 73.1 minutes. Meaning if you get on the ferry, you better plan for at least 96% chance of at least being 73-minute long ferry ride, right? So this one was working backwards, and we had the issue of the inequality that we had to look at. Okay, so let's look at another question. Okay, let's look at the next question here. Notice if we go down to the main question, it says the heights of students at the mainland college are normally distributed with a mean of 148 centimeters and a standard deviation of 8. The probability that a mainland student chosen at random has a height less than 8 centimeters is 0.67. Find the value of h. We're not going to do this particular part because it was just like the last one we did. It gives us the percentage, the probability, 0.67, and you have to work backwards to find the variable, your random variable height. So since we just did an example of that, I'm going to skip the 0.1 or the part I here and go on to the II. Now notice this one says there's 120 students that are chosen. So here we have 120 students, and it says find the number of these students that would be expected to have a height within half a standard deviation of the mean. Okay, so let's get back to the board here. Okay, so out of our 120 students, it says find, this was our II part here, we didn't do I, find the expected number. So remember, expected number is now the probability times the total number. So we have to find the probability, multiply it times the total number to get the expected number. So here's our keyword here, find an expected number. And this is the information it gives. It says a half a standard deviation from the mean. What's important for you to understand here is that your mean is the average, and your half standard deviation needs to go both directions. So it needs to go this way. That's the positive direction. That means it's going to be a 0.5 standard deviation that way. And it also needs to go this direction, which would be a negative 0.5. So it is a half from the mean. So half this way is in the positive direction, half this way is in the negative direction. So we want to find the number of these students that fall between there. Now, you don't actually have to go back to the notation for this. And you don't even have to make a probability statement since we don't know what those actual heights would be. What we have is what we need already, and that's our z. Our z value is the standard deviation. It's a 0.5 standard deviation. This isn't the deviation itself. It's a 0.5 standard deviation, means on our normal scale. So our z equals 0.5000, and our z also equals a negative 0.5000. So what we just need to do is enter this into our phi z chart. And when we enter this into our phi z chart, if we look up 0.500, or sorry, not 0.500, just 0.5 on our chart. I guess it doesn't matter. It's usually 3 decimal places, so we can put 2 zeros. We're not looking at probability here. This is the z value. Z value is this 0.5 from the mean, it's your z-score. It's not the standard deviation that they gave in the problem, it's 0.5 standard deviation. So it's a little different, but if you recognize it as the z-score, it will help you figure this out a little faster without recreating your probability statement. So if we go to 0.5, which is right here, 0.50, of course there's no 0 over here. So 0.5 of a standard deviation, which is our z-score, gives us 0.6915. This is the probability. So our probability is 0.6915. And then on the other side, since it's negative, when we look up the phi z chart, of course, you can't look up a negative number. So that means you need to do 1 minus 0.6915. Okay. So that was right here, 0.5, and then the negative means we do 1 minus that. So let's come back here. Again, this all depends on whether you recognize this half of a standard deviation, that this 1/2 in your normalized system, your z represents the standard deviation in the standardized model. So if it's half a standard deviation, that means you have a z of 0.5. So I hope you can recognize that. Saves you a lot of time if you do. And this is our one probability for the right-hand side. Again, we're looking for between, so that means we need to do the large value minus the small value to get the in-between value. So this one here, because we had to do the 1 minus because it was negative, gives us 0.3085. So now we can take these two. Here's the large one, 0.6915, minus the small one, 0.3085. That will give us the between value. So let's do that real quick. 0.6915 minus 0.3085 gives us 0.383. So what this means as a percent or as a decimal, this is your probability, means that 38% of your students fall within a half standard deviation from the mean. Well, what it wants is what's the expected number? And it's out of 120. So if 38% of those 120 are going to fit this criteria, we need to multiply. So 0.383 times 120 gives us, times 120, means we expect 45.96. Now, since we're dealing with people, you can say 46 people. They'll allow you to give the decimal, but if you're thinking about practical situation here, that we can, and this is an expectation. Remember, probability is kind of like a prediction. It doesn't have to be, exact. So 45.96 is roughly, we can expect 46 of those people to be within a half standard deviation of the mean. So this then, 46 would be our answer. If you happen to feel like, well, I can't go more than that, and you rounded it down to 45 because it wasn't yet 46, they would accept that as well. You could give 45 or 46, and hopefully you don't do 45.96 because you can't have a decimal of a person. So remember, math isn't just doing calculations, it's thinking about what you're doing. So let's look at the next question. Okay, here's our last question, and let's go right to it first so that we can read it and see what it says. It says, it is known that 20% of male giant pandas in a certain area weigh more than 121 kilograms. And 71.9% weigh more than 102 kilograms. Weights of male giant pandas in this area have a normal distribution. Find the mean and standard deviation of the weights of male giant pandas in this area. Notice it's 5 points. So let's go back to the board and think about this a little bit. First off, we're dealing with weights. Weights of these giant pandas. So that's a continuous concept. Weight is not discrete values. It can be anywhere in between along a range. So this is continuous. It does say normal distribution. And it gives us these two statements. And it wants us to find mu and sigma, the mean and the standard deviation. So in this question, what we're doing is we're finding the parameters, which in our little map are right here in the middle. So we're working both ends to the middle. And here are the both ends. We have our specific value, our little x, a particular representative weight, and we have the probability that goes along with it. And so we need to work both ends to the middle. And because there are two variables, we need two equations. So as soon as you see find mu and sigma, you should know where they're at on the map. So we have to work towards the middle. And because there's two variables, we need two equations. So first, let's write our notation that we need to do. So our random variable, which is weight, is distributed normally, but we don't know the parameters because we have to find them. So we're just going to leave it as mean and variance, which is the square of standard deviation. We don't know either of those. And our probability statement, there are two of them. So the probability that our random variable is more than, it's greater than 121 is equal to 20%, 0.20. Okay, so the probability that the weight, this is a weight and that's a particular weight, is more than 121 is 20%. And the probability that our random variable is more than 102 kilograms is 71.9%. Again, you're going to change it to a decimal, 0.719. Okay, so a couple things you should notice. You should notice that both of them have a greater than sign, and our phi z chart needs a less than sign. The good news for this one is we can choose to do 1 minus the probability. So on this one, we can change this to the probability that x is less than 121 and just do 1 minus 20% is 80%. And the reason why we do want to do that is because we can't look up 0.20 on the phi z chart anyway. It starts at 0.5. So we made the adjustment by flipping the inequality, because that's what the phi z chart is in, the less than, the chart is for less than, and we did 1 minus to the probability. So this is what balances this. We made this change, so we either have to choose this, or when we get over here, if you notice, we also have a greater than, but we can't. Even though we want to flip the inequality, we can't yet, because if we do 1 minus 0.719, that's going to give us 0.281. And we can't look up 0.281 on the phi z chart. So whereas on this one, we were able to make that adjustment right away, This one, we can't make the adjustment until we get to the z number. Then we can still use this probability, but we have to change it to a negative z because we want to flip the inequality. So that's the issues that we're dealing with. Now we want to take our probability that we can use, and we want to go backwards into our phi z chart. So let's first look at this 0.8 here, 0.8, and let's go to our phi z chart. So here's our phi z chart. I think we can get rid of this for now. So let's pull this up and make it a little bigger if we can. So we're looking at 0.80, which is right here. Here's 0.7995, and this one's already 0.80. So we need to find the z value. So the z value is a 0.8 and up here to 4. So that's right here. This is where we want our 0.7995 is a 0.8, 0.84, and then the third digit, in order to get 0.80, we need to add 5. So we go over here to the 5, follow it up, and it's a 2. Okay, so it's 0.8 is the first decimal, 4 is the second decimal, and 2 is the third decimal. So that is our z number. And then for the other one is 0.719. Remember, these in here are probabilities, the probabilities. So the probability was 0.7 or 71.9%, 0.719. So we look at 0.719 and notice right here exactly 0.719. It's exactly what we want. So the z is going to be 0.5 and 8. So 0.58. And because we want to flip the inequality, we need to make it negative. So a negative 0.58. Now we can come back to our board here. So we looked up the probability. We went from the probability to our phi z chart, and we looked up the z number, and we got 0.842. Remember, this was a 0.7995, which gave us the 0.8 and the 4, and then we had to add 5, which is where the 2 came from. This one was exact, 0.58, but because we want to flip the inequality, then we have to make the z negative. So those are your two choices. You can either do 1 minus the probability, which in this case was to our benefit. In this case, we couldn't, so we had to wait until we got the z number and make it negative. Now we can make up our system of equations. We need to find these two variables. So now we're working with this right here, okay? So I'm going to go ahead and just multiply the sigma over so that we can speed this up a little bit. So if we just multiply the sigma over, so what we want is x minus mu equals z times sigma. So over here on this one, we get our x is 121 minus mu, which we don't know, equals z times sigma. So 0.842, and we also don't know the sigma. So there's our variable, just 0.842 times the sigma. So this is our one equation. Then this equation over here is our x, which is our 102, minus our mu equals a negative 0.58 times the sigma. So here's our two equations for our system of equations. So we've worked the probabilities and our x values into the middle for a system of equations. Now I'm going to bring this one over here. 102 minus mu equals a negative 0.58 sigma. And if we want the mu's to cancel, all we have to do is subtract. So minus a negative makes a positive. A negative mu plus a mu cancel out. So 121 minus 102 is 19. A negative mu minus a negative mu, or a negative mu plus a mu, cancels, equals, minus a negative means we need to add. So we need to add 0.842 plus 0.58, and that gives us a 1.422, 1.422 for the sigma. And then of course, hopefully that you can just follow the algebra. Divide by 1.422, divide by 1.422, and that's going to give us our sigma. So 19 divided by the answer gives us a 13.36. Sigma equals 13.36. Of course, we want it to 3 decimal places, so I'll put it over here. Our sigma equals 13.4. That's one of our answers. Now I'm going to use the 13.36 because it goes to 4 significant figures for our work, because we want our answer in 3 significant figures. So over here, we're going to put 13.36, and we're going to solve for mu. So notice if we add mu over here, and then add this one this way, it's 102 plus 0.58 times our 13.36. So this will give us our mu. So we add the mu to the other side to make it positive. We add the 0.58 times 13.36 to this side with the 102. And so 102 plus 0.58 times 13.36 equals a 109.7. So our mu equals 109.7, but because it's actually 7488, but actually we want 3 significant figures. So here's 1, 2, 3. Remember, zeros in the middle are always significant. 1, 0, or 1, 2, 3. So that means this 7 is going to round that up to a 110. So our mu is equal to 110. Of course, that's the 3 significant figures. These are our 2 answers, 2 variables, simultaneous equations. They give you both statements. Again, write your notation, write your probability statements, take your time finding your way through the map, pay attention to the details like these greater than, less than signs with respect to your phi-z chart. Also pay attention to whether or not you can do 1 minus to the probabilities. This one, put your number over 0.5000, which was good. This one you can't, so you had to wait till you get to the z and make it negative. So this should give you, with all of these 4 questions that we've looked at, it should give you a pretty well-rounded idea of the different ways Cambridge can ask this normal distribution question. So I hope you really paid attention and took good notes on the part 3A. Your mental understanding is very important. That's where most people make their mistakes. The math isn't really that difficult. Simultaneous equations you learned back in junior high school. So the math of this isn't too difficult. I hope that helped. And again, as always, thank you for joining me. I look forward to seeing you again next time.